In this video, we're going to use another max object to create a state variable filter. As with the degrader audio effect, we're going to be using a single MSP object to do most of the work. Add a max for live audio device to an audio channel and open it for editing. Type N for a new object, type SVF tilde. Let's sum the audio inputs to mono at the input of the SVF object. To see what the SVF object does, take a moment to mouse over each of the inlets and outlets. Let's add a live.dial to control the filter cutoff frequency. Connect the output of the live.dial object to the second inlet of the SVF object. Enter the inspector for the live.dial from the contextual menu. Change the range to 0.15000. This will be our frequency range. The range of values output by our live.dial are linear. Since frequencies are exponential, it would be good if our dial's output reflected an exponential output. We can change the output of our dial by setting an exponential value. Find the exponent attribute in the live.dial's inspector, click in the value column and type 3.3333. Let's change the units we're displaying. Click in the value column for the units attribute and choose Hertz from the pull-down menu. Let's label our dial, set the short name to frequency. Also change the long name to frequency. This will make our dial visible in Live's automation channels. Now let's set up our device so that its default state is to have the cutoff frequency set to 15,000 Hz. Click the Initial Enable checkbox. Set the initial value to 15,000. Let's add another live.dial to control the filter resonance. Connect the output of the live.dial object to the third inlet of the SVF object. Enter the inspector for the live.dial from the contextual menu. Navigate to range and type in 0.1. For the new range values. Change the dial unit attribute to float. Set the live.dial short name to resonance, and also change the long name to resonance, which will make this dial visible in Live's automation channels. Since we want to start our device with its resonance set to 0, we don't need to set an initial state. The SVF object outputs all of the differently filtered audio signals at once, so we need a way to choose which of the outputs to use. Add a selector object to the patch with an argument of 4, which specifies that there are 4 possible inlets. Note on switch input, 0 means nothing passes. Add a live.tab object to our device for choosing which filter to apply to its input signal. Instead of typing in filter names into the inspector, we're going to work with a prototype. There is a prototype for using filters already built into Max for Live. We're going to use it as a starting point to make our own interface. To change to a prototype, control-click on Mac or right-click on Windows on the live.tab to access the contextual menu and navigate down to Prototypes and select Filters. The live.tab object you created will disappear and be replaced by a new grid of 6 pictures representing different kinds of filters. Since the SVF object outputs only 4 kinds of filtered output, we'll need to edit our live.tab object so that it contains the right number and type of filters. To do this, open the live.tab objects inspector and locate the image files attribute listed under the Pictures tab. You'll see 6 different SVG graphics files listed whose names represent a type of filter. Remove the names high shelf and low shelf from the filter listing. Also remove the names high shelf and low shelf from the range attribute. When you do this, you will see that the live.tab object now has 4 buttons matching the types of filtered output that the SVF object produces. Take a more careful look again at the name and order of the outlets of the SVF object. They have the same filter types as the live.tab object, but they're not in the same order. We'll fix that difference when we patch the SVF object with the selector object. In addition to choosing a specific inlet, the selector object lets us specify no input by sending it a value of 0. The live.tab object sends a number corresponding to the button we click on in the range of 0 to 3. In order to choose a filter output, add a plus object with a figure of 1 and connect the outlet of the live.tab object to its inlet. Connect the object's outlet to the first inlet of the selector object. Connect the first outlet of the SVF object, the low-pass outlet, to the fifth inlet of the selector object. Connect the high-pass outlet to the second inlet of the selector. Connect the bandpass outlet of the SVF to the third inlet of the selector, and the notch outlet to the fourth inlet of the selector object. Add a live.gain object to the patch to provide volume control. Let's change the orientation of our gain slider to horizontal in the inspector. Connect the outlet of the selector object to the inlets of the live.gain object. Now connect the audio channel outlets of the live.gain object to the inlets of the plug-out object. Add the two live.dials, the live.tab and the volume slider, to presentation mode from the contextual menu. Change the patch into presentation mode and move the UI objects into a position you would like them to be when you close your device. Set the device to open in presentation mode when we launch it. Save your device. Now we have a fully functional state variable filter.